Average speed. Average speed. It is defined as total distance by total time. Total distance is indicated by d and total time by t. Then it will become v bar is equal to d by t. This is the relation used for finding average speed. Speed is not a vector quantity, so it has no direction. It has only magnitude. Position time graph. Position time graph. Suppose if a body is at 50, plus 50, then if it is always at plus 50, so it is constant. That is indicated by a horizontal curve shown in the graph, constant position. If it is moving to the right, then its position will be increasing. So if it is moving to the right, then its position will be increasing. It is shown by a curve inclined upwards. Another curve inclined downwards indicates decreasing position. That means the body will be moving to the left. Initially, if it is at 50 and if it is always at 50, it is represented by horizontal line. If it is moving to the right from 50, it is shown by increasing position, and if it is moving to the left, it is shown by decreasing position. Non-uniform motion. When the object moving along a straight line, say x-axis, travels unequal distances in equal intervals of time, we say the object is in non-uniform motion. Examples: bodies falling freely or bodies thrown up vertically, initially with some velocity. The displacement, the position time graph of such a motion is represented in the curve, in the graph. The curve shows the relation between position and time. In fact, for a body falling freely, it will be a parabolic path. Also for a body thrown up vertically, it is also a parabolic path. Average velocity. Average velocity is defined as total displacement by total time. If the total displacement is s bar and the time taken is t, then v bar is equal to s bar by t. In another way, suppose if a body is at position x1 at time t1, it is at the position x1, and after time t2, at time t2, it is at the position x2. If it is at the position x2 after a time t2, then total displacement is x2 minus x1, which is represented by delta x. Total displacement is x2 minus x1 represented by delta x, and total time taken is t2 minus t1 represented by delta t. So the ratio delta x by delta t, which is equal to x2 minus x1 by t2 minus t1, is the average velocity. This average velocity depends on initial position and final position. It depends on only initial and final positions. No details of the path followed will be obtained from this average velocity. It is a result of the motion. I will show this in the next slide. To have a concept of delta x and delta t, let us take the curve shown in the figure. P1 represents the position of the particle at time t1. P1 represents the position of the particle at time t1, and P2 represents the position of the particle at time t2. Then the straight line distance from P1 to P2 is the displacement of the particle. This displacement is given by x2 minus x1 which is the vertical dashed line. The dashed vertical line represents x2 minus x1. The horizontal line, dashed line, represents t2 minus t1. t2 minus t1 is represented by horizontal dashed line. So, delta x is x2 minus x1 and delta t is t2 minus t1. So, we cannot obtain the information, the path followed from P1 to P2, but we can obtain the initial position, the result of the initial and final positions. This is how we have to understand the displacement and the time taken for finding the average velocity. Concept of the change in average velocity with change in the time interval. Delta t is time interval. As delta t approaches 0, that means as delta t is made as small as possible. This concept is indicated in the curve. Locate the several positions of P2. The initial P2 is take it as the extreme P2 and then take the P2 close to P1. As it comes close to P1, the time interval delta 2 becomes small and small. As this time interval becomes small and small, the position of P2 approaches P1. As it approaches P1, the line P1 P2, the straight line P1 P2 approaches the tangent to the curve at point P1. The tangent to the curve at point P1. So, ultimately it becomes a constant. Ultimately, this delta x by delta t becomes a constant as the time interval is made as small as possible. Definition of velocity. Velocity is defined as the rate of change of position with time. Velocity is defined as the rate of change of position with time. And this is called instantaneous velocity. This is called instantaneous velocity. The rate of change of position of a particle with time is called instantaneous velocity. This is mathematically written as limit delta x by delta t as delta t tends to 0. Limit delta x by delta t as delta t tends to 0. Already we have noticed that delta x is the change in position and delta t is the time taken and delta x by delta t is average velocity. As delta t approaches 0, delta x by delta t reaches a constant value. That constant value is represented by dx by dt. This is the definition of velocity. This is instantaneous velocity, and the direction of this velocity will be a curve tangential to the path, a displacement time curve at the point P1. It is a tangent to the position time curve at the point P1. Average acceleration. Average acceleration. Average acceleration is the rate of change of velocity. That is the ratio of change in velocity to the time taken. Delta v is the change in velocity and delta t is the time taken. So, total change in velocity by total time. This is average acceleration. Delta v is change in velocity. So, if v1 is velocity at time t1 and v2 is the velocity at time t2, then v2 minus v1 is change in velocity and t2 minus t1 is the time taken. So, the relation for average velocity becomes equal to v2 minus v1 by t2 minus t1. Definition of acceleration or instantaneous acceleration. It is defined as the rate of change of velocity with time, and it is mathematically given as limit delta v by delta t as delta t tends to 0. That is the ratio of change in velocity to time taken approaches a constant value as the time interval approaches 0. As the time interval is reduced, it becomes small and small. The ratio delta v by delta t approaches a constant value. That constant value is denoted by dv by dt. This is instantaneous acceleration. To understand the effect of acceleration, let us answer the following questions. Suppose the acceleration of a body is 5 meters per second square. What is the increase in velocity in 2 seconds? When we say acceleration is 5 meters per second square, the velocity increases 5 meters per second in each second. So in 2 seconds, the increase in velocity will be 2 into 5, 10 meters per second. If initial velocity is 10 meters per second, what is the velocity after 4 seconds? The velocity increases at the rate of 5 meters per second. That means in 1 second, the increase in velocity is 5 meters per second. In 4 seconds, the increase in velocity is 4 into 5, 20 meters per second. In 4 seconds, the increase in velocity is 4 into 5, 20 meters per second. Already, it has 10 meters per second initially. So, the total velocity becomes 10 plus 20, 30 meters per second. 30 meters per second. What is the rate at which the velocity increases? That is 5 meters per second. What happens to the velocity if acceleration is negative? The velocity decreases. What is the change in velocity if acceleration is 0? There will be no change if acceleration is 0. The change in velocity becomes 0 if acceleration is 0.